So everyone knows.
Cool. Well, thank you all for joining. I will be doing the presentation for the brown bag, mastering your dev environment, mainly mastering Docker files, Docker Compose, and how to use them in your day-to-day workflows, or hopefully use them. The talking points is, as I just mentioned, Docker files, Docker Compose, and workflow. I use this all the time in my personal projects, and especially in full stack projects. Just it makes life so much easier. And where I want us to get started is Docker files, because this is where a lot of complication comes for people who haven't messed with Docker before. And it's a little bit small to read on this slide. Next slide will be a little bit bigger. But what is a Docker file? The Docker file is the instructions in which creates the container your code's going to run in. Very short, sweet answer for that one. But when you read a Docker file, it's best to read it as a list of instructions to set up the environment the code's going to run in. And it's a little easier by showing you a multi-stage Docker file. So this has been broken down into multiple stages so we can kind of walk through what each of the stages is doing and how that kind of affects how you're going to use Docker files and utilize them for your own personal projects. So in this one, we're starting at the top line that says from Ubuntu latest. That is the base image or the foundation we're going to build on top of. So the best way to kind of think about this one is if you made a virtual machine or you installed Ubuntu raw onto your computer, this is where we're starting. The next thing we're doing is we're running a bunch of commands in order to let us use Node on this Ubuntu image that doesn't have a Node CLI running or anything like that. So much like I said, we're running the instructions to set up the container to be in the state in which we need it. So I have this broken down into multiple stages. So this first stage, which we're naming prepare, is this Ubuntu that can run Node. That's all it is. It's a base Ubuntu with a base Node installation. From there, we take that as if it was from Docker Hub or another image registry, and now we can build on top of it. So stage 2 here is taking prepare, and we are now setting up our dependencies for a Node project. So I am copying the package JSON in from the directory or the folder in which this Docker file exists, pulling that package JSON in, pulling in other things, and I'm running npm install, well, in this case, yarn install. But I'm running an install to get the dependencies, which creates the Node module. So now, stage 2 of this Docker file, or what could be its own Docker file, is an Ubuntu image that has my project's Node module folder existing in it. Little bit of a kind of bonus thing here is by doing multi-staging, each stage only runs when changes of the stage's data changes. So in this case, if package JSON changed, we would run stage 2 again. So that's optimization stuff for when you're talking about deployment and things like that. But moving on, stage 3 is where we're actually going to kind of run the application, whatever that application may be, and do the final updates and get the final bit of data we need to run it. So this is where we're copying, in this case, because we're doing a Next.js app in this instance, we're grabbing all of the app data, copying it into this image, and getting it ready to run. We have to expose a port because the container is its own little system that we need to expose what the outside system can interact with. So expose exposes ports. The command here is what's going to run when I run Docker run this container. So a little bit complicated file here. I chose to do the multi-stage so that we can kind of see what a base image looks like and how it's being used. To kind of reiterate that point, that Ubuntu image at the very top is its own Docker file that's doing a bunch of things to run Ubuntu for your base image. Yeah, so that's the Docker file. Now, the nice thing about Docker files is you can run them on their own using the Docker CLI, or you can use Docker Compose. Docker Compose is a utility CLI tool that lets you create a single file to run multiple Docker files, containers, and stuff like that. On the right-hand side, this is what a Docker Compose YAML looks like. And this is one I run for one of my personal projects all the time. And the thing I want to point out in here is I have a few services, as they're called, that are running a build command. The build is finding the Docker file, and then it's running the Docker build on that file. So what we saw in the multi-stage or other Docker files that exist, we're able to build them using Docker Compose. The other thing to point out is this DB line down near the bottom. This is grabbing the Postgres image to run me a Postgres database in the Docker Compose network that it creates. This is super useful because now I can run specific databases without installing them on my computer. I can work with them as if they're on my computer by exposing the ports and make them persistent by using this volumes thing. I'll get into that in a moment, but the main thing I want to kind of point out is how Docker Compose is letting me run my entire full stack application that has a separate front end and back end in one command. And exposing ports so I can interact with it and continue my development. Going back to the database and this volume section, by default, each container is temporary. You can easily do a command to delete all your containers, which deletes the entire state of that container. So when dealing with databases, that means all my database tables, all my database setup, actual rows, all of that is temporary unless I connect it to a volume. That volume now makes it persistent, and the volume exists in the directory of my Docker Compose file in this case, right? Current directory / data now contains my entire database for this project. That's very useful for persistency, and when I take the Docker Compose file down versus Docker Compose up, I will have a persistent, ever-living database that I can interact with, I can develop against, and I can visualize. The other cool thing about using Docker Compose for building your full stack applications is, if you notice, I have this environment file line, can't think of what it's called now, that has a .env file. Docker Compose can read .env files, and now I control my entire system's environment variables from one .env file that I can easily look at. I believe my next slide shows that. So that .env file, I have it broken down from my client to my API to my database environment variable stuff. And I can easily manage my entire environment from this environments file, which just speeds up your full stack applications while doing best practices. Each of the services are reading from the same environment file, which means I could actually have multiple environment files, one for each system if I wanted to, or I could set up the Docker Compose to run. I can change it to run a production ready one or a testing environment one. There's a lot of flexibility by using the environment files in this use case. Moving on, this is, again, a little bit small, but these are the screens you'll see when you run Docker Compose. Starting on the top left, that's it grabbing images from the registries and downloading them onto your machine. You can then see on the right of that where it's telling you what step it's currently working on. This is great for debugging purposes, obviously, as well as if you look at that when you're working on multi-stage Docker files, you can see that it skips a bunch of steps because you didn't change any of those files that it needs to work with. So it can speed up your development time and build time because it doesn't have to go re-download all your node dependencies. It can just run with what you've got. Down at the bottom is the logs that it'll generate. If you notice on the left-hand side, it colors each of the services and provides the name that you called the service. And for more complex use cases, you can have multiple services of the same name and so on and so forth. But then I have access to all my logs from each of those services. Again, speeding up my development time because I have everything in one spot. One of the cool things that I learned while working on the practice app here at STG is I can actually declare what services I want to run. Didn't know that before. It's an awesome thing. Before I was just commenting out some of the Docker Compose stuff that I didn't need to run while I was running the other service, in this case, running my client normally while using the API database in Docker Compose. This is how I develop very regularly, is I pick, am I working front end, back end? Cool. I'm going to run the other service while I'm developing on my actual machine. And it all just flows very naturally. One of the tricks with that is using .env files in your client project or your server to make sure it reaches to the local host instead of the network name in the Docker Compose file. I talk really fast. That was a lot of information. I also like to leave a lot of QA space. So that's kind of what we're going to go into next. But some of the takeaways here is how to use Docker to help you build production-ready code and production-ready environments and stuff like that, because your Docker files are what will make it all the way through the process, hopefully. Using Docker Compose to replicate the environment in which the final code is going to go into makes it a lot faster and makes me personally more confident in my code because I'm seeing it communicate across a local network as if it was communicating across a broader network like AWS and stuff like that. And yeah, if you can build it in your Docker file and you get it up and running in your Docker file, you can have a lot more confidence in it working in a production environment. Ta-da! So with that all said, any questions? Go for it. Can't hear you, Sean. Well. Oh. What's up?
Can you hear me okay?
Yes.
Oh, good. I'm assuming we'll have access to these slides just so that I've been writing down notes, but to refer to it.
Yes, I will probably share the slides with Jen, but I'm also going to take the opportunity to write an STG blog post on this subject as well. So
Oh, awesome.
You can do the slides, or you can wait until I have a more fleshed out, thoughtful blog post.
Great. That's good to know. Where can I access the blog?
I have no idea.
I'll just do a little Google search.
Consulting.com is where our blog will be. I'll put it in the chat.
Oh, perfect. Thank you.
And then I believe Meetup has a feature where I can add the slides there. So I will try to add the slides there.
We'll get that all worked out in the coming weeks. Any other questions? Okay, so Sean sent a message saying, if I understand correctly, the Docker file has instructions. The Docker Compose knows about the environment you are installing to. Kind of. So the Docker file creates an instance. It's called a container. But a way to kind of think about it for a lot of us is like a virtual machine of the environment in which your code's going to run. The Docker Compose is creating the network of connecting your virtual machines, right? And providing some naming things. I believe I had it in my example here. If you look at the API URL that I have commented out, you'll see I have API : 8001. Docker Compose created this bridge network, is what it's called, to my knowledge, that is it is kind of a local network that the containers can communicate across. So when the client is in the container, it needs to communicate with API as the host name instead of localhost. And it communicates like that. So in my head, it's always made more sense for Docker Compose to be the networking side of things for your local machine. That has always made more sense to me than thinking of it as the environment. The Docker file is creating the environment. R. Hall asked, where's a good place to start doing things on your own? Actually, fun thought or fun fact, this multi-stage Docker file, I use ChatGPT to create. So you can use ChatGPT, Google, or something like that to create your base Docker file image for the code you're wanting to run. There's a lot of examples out there. So before ChatGPT, I used just Google. I would Google, like this one here, that's very basic, straight up copied it offline, going like, hey, I need a Golang Docker file to run my code. And it goes like, cool. Someone on Stack Overflow or ChatGPT will be like, hey, here's the bare minimum you need to run your Docker file. To understand the commands and stuff like that, I would recommend to just kind of look on YouTube and see if your favorite creator has talked about it or not. But as far as like books, websites, and stuff like that, you're going to learn more by trying to move your project into it and finding the questions you need answered along the way and Googling those. Anything else?
Hey, Justin, would you recommend starting with a Docker or creating your project first and migrating it to Docker?
So it depends on the complexity of your project, right? If you're doing a simple, let's say Next.js application, right? And you're not trying to do any kind of weird build steps. You're not really doing anything weird in terms of moving files around, generating files, or anything like that. Then you could build the project and then make a Docker file for that project. If you need the restraint to prevent you from doing weird things, maybe starting with the Docker file is a great idea. One of the other things you can do, thank you for asking the question though, and to answer someone else or to answer the good starting place, is if you use Docker Compose just to run your database, you can start getting familiar with it, right? You don't have to write your own Docker file. You can just use other Docker images out there for your database. You can do Redis. You can do Kafka, I bet. I haven't done it, but I bet you can. You can do all those toolings that are used for your program and build a Docker Compose file that just grabs those. So you have an instance that's running your infrastructure stuff, as I like to consider that. Docker is relatively easy to install on Windows and Linux. There is, well, Mac and Linux, there's a little bit of a thing to be aware of in terms of access to it and understanding that Docker runs everything as admin, I want to say. I can't remember the exact terminology now. Windows is a little bit easier because there's an actual desktop application they give you, Docker for Windows, where you can see your containers running and stuff like that. So, and that should install everything for you. But yeah, I would say on a scale of 1 to 10, for Windows, 3, maybe on difficulty. For Mac and Linux, 6. If you know what you're doing, you'll be fine in terms of organizing your users correctly. But for the most part, it's just install and run. Yeah. So Philip brought up that the dashboard on Mac will show you containers as well. So yeah, Mac and Windows obviously have better support in terms of raw or as far as a GUI goes. So it shouldn't be too hard to run and manage.
Could I ask a question that might not, it's kind of not totally related. I'm just curious because you're talking a lot about Next.js, and it sounds like that's your preferred way to build a React app over just create a React app. I'm just curious. I'm just curious about your reasoning because I've been trying to decide which way to go with an app I'm going to build.
So on that subject, either go Vite or Next.js. Next.js just gives you a backend with it, so you don't have to worry about during deployment, how am I going to serve my React app? Next.js also provides a lot of built-in tooling. So it's just kind of a yes and to React in a lot of ways.
What was the first one? The first option you said?
Vite.
Okay.
So create React app is being considered deprecated, and it comes very filled with vulnerabilities now. Vite is a build tool similar to Webpack that is becoming the standard across all frameworks and stuff like that.
Oh, good. That's good to know because I had to resolve some dependency issues.
Yeah,
Yeah.
no, create React app, don't use it.
Cool. Thank you.
Yep, not a problem. Any other questions, concerns, thoughts, suggestions? It's on. Thank you. Cool. Sounds like we're good.
Thank you, Justin, for a great presentation.